Okay, let's get back to the Virtual Jug conference, and we are now on session 19 out of 24, and our next session is Radically Reactive Web Apps with Eclipse Vert.x, and our speaker for this session is Burr Sutter from Red Hat. And are you with us, Burr?
I am. Can you hear me well?
I can hear you just fine, thank you. So great to have you join us. Is this your first session as well on the Virtual Jug?
It is my first time. I'm a Virtual
Okay.
Jug virgin.
Well, congratulations and welcome. It's always a pleasure speaking to you, Burr, at conferences, and it's great to have you on the Virtual Jug.
It's an honor and a privilege, and I look forward to it. I think we'll have some fun tonight.
Let's hope so. This will be a good session, I think. Our sponsor for this session is Lightbend, and participating jug is the Ecuador Jug. We'll speak to them in just a minute. So yeah, Lightbend are our gold sponsors, so we thank them for their support of the Virtual Jug, and do make sure you head over to their site as well to hear about lots of fun things like Akka and Lagom and lots of other great things. So yeah, do check them out. And Zero Turnaround, of course, the sponsors of the Virtual Jug. If you're interested in being a more productive developer or understanding how you can be more from a performance point of view, we are getting a large amount of feedback. I'm just muting Ecuador Jug just for a second because I'm getting a bit of feedback.
Right.
But there we go. So yeah, Zero Turnaround are the sponsors. So if you're interested in JRebel, or like from a productivity point of view, the faster development of your Java applications, or you're interested in learning how you can pull your performance testing earlier into development and test with XRebel, do go to zeroturnaround.com to check out some of the free trials there. But how are we going to run this session? Well, if you are wanting to have some great discussions and ask questions of the speaker, you can go onto Slack, and we have a live session channel where you can have your discussions and ask your questions, and I'll put them straight to Burr live on this session. You can also tweet hashtag vJUG24, and if you're just joining now, please make sure your video quality is at its highest by clicking on the settings cog at the bottom of this window, and just cranking that up as high as you can. So let's see who we have. We can see Burr. There we go. There's Burr. How are you doing? Burr, whereabouts are you calling in from today?
I'm in the Wake Forest area of North Carolina, not too far from Raleigh.
What's the temperature in North Carolina right now?
It actually got a little cool tonight. So in Fahrenheit, I don't know the Celsius, but it's like 60 degrees Fahrenheit.
Okay. So that sounds cold.
No, it's not cold. It's just kind of
regressions between builds, between things, and it will give you that information which you can then diagnose and fix using XRebel. So there's really interesting new developments in cloud performance management over on zeroturnaround.com. So do check that out. For those of you who are
There we go. Sorry, Ecuador. Ecuador. I'm just muting you until we need to hear from you, because unfortunately there seems to be a bit of a delay, so we can hear ourselves back. But that's 15 degrees Celsius, which is is still warmer than the UK. So you don't have my sympathies at the moment. Okay, so we'll. It seems like the Alberta jug. Sorry, the Ecuador jug is actually a little bit behind. So. Let's when you hear this, if you could unmute yourself and say hello. Oh, there we go. So not too far behind. Please, yeah, go on then. Let's unmute, and we can say hello.
$10 seconds.
Can't hear you yet.
Jump up and down in front of the camera.
I muted you on Hangouts. So if you unmute yourself now through the Hangout. You have 3 more seconds. 2, 1. We'll speak to you later. Okay, Burr, over to you, and the stage, the floor is yours, sir.
All right. Well, I'm going to screen share. Hopefully everything sounds okay and will look okay. And we're going to jump over here to the slide deck. I added the link to Slack, by the way. So the tweet that I sent out with the slide deck link in it.
Awesome.
So You guys will have access to the slides. They're live deck. Often I come back to these and edit them, so you might see me make changes in the future. But specifically, I'm part of the Red Hat Developer Program, so just be aware of that. So if you go to developers.red.com, you'll find out more about what we do at Red Hat, specifically for developers. And this is a super fun session. At least I think it's super fun, and I'm hoping you guys find it to be fun too. We have a bunch of live demos that we'll do, including ones where I need your participation. The folks down in Ecuador promised me they were going to be ready with their smartphones to really do some cool stuff for us when we get to that point in the presentation. But the link down here, bit.ly radical web, that is going to get you access to this live deck. So literally you could just join up and start right now. You can see someone's already joined, Anonymous Manatee. So feel free to dive right in there. All right, so let's get into this. I always love talking about developer evolution. For some reasons, it's been stuck in my head now for 20+ years, and I've been using these same images now for quite some time. But in the case of the developer, if you think back towards the 1970s, when we were programming, we had to learn two technologies, COBOL, and our mainframe, of course, and then either JCL or Wiffle. And the cool kids, they had IBM mainframes, and they used JCL. Me, I wasn't so cool. I had a Wiffle machine, meaning a Unisys or Sperry machine. So, you know, workflow language for those people who weren't cool enough to have job control language. But in the 80s, it got more interesting. And actually, the 80s is when I started programming. My interaction with the Unisys mainframe was actually because, you know, those things stay around forever. And that was actually in about 1988 or so. But C++ and C, I got into C programming in a big way in the late 80s. But 4GLs were also born, fourth generation languages. And I actually did a lot with that technology. Maybe you were interested in computer-aided software engineering, you know, CASE, back when we used to draw diagrams and hope that it generated COBOL code for us. I was even a NetWare administrator for one period of time in my life. So a network administrator, setting up NetWare machines by Novell. Most people have forgotten about NetWare at this point. It's kind of sad. But there's lots of stuff that's happened. And actually, the 90s is when things started getting interesting. So we actually quickly jumped from green screen, amber screen, you know, 5250, 3270, VT100, VT200, you know, 320, into the web world, right? Or actually the client server world, right? We had Windows machines talking client server to Unix machines. And then we went into the web world pretty rapidly around the mid 90s there. So HTTP and HTML, and we learned about GET and POST. We learned about cookies. We learned that cookies were, you know, horrible things and terrifying. Even back in 1997, I was explaining to people that a cookie was not going to steal their identity unless you give the person your information. But people were terrified of cookies even back then. It's really fun when you visit websites in Europe now. They all warn you about the cookies and stuff like that. I think it's pretty fun how terrifying cookies are. But in the 00s is when things got really interesting for us as web programmers. So, you know, the pretty basic stuff back in the mid 90s to the late 90s, it got really interesting in the mid 00s, right? Around 2006 or 2007 or so. We got Ajax as one example. And we were able to do some really neat stuff by interacting with our front end. Again, it goes back to client server architecture, interacting with the back end. So we might have had JSF or Spring MVC or struts or something of that nature on the back end of the system. But our front end became a much richer client when JavaScript really came into the foreground. And then I'd put this 2010s here because we had to start thinking about mobile in 2010. You know, we have all these, you know, we have React, we have PWAs now, you know, progressive web applications. And it's just kind of the world was blown up. It seems like everything is, you know, crazy at this point. And reactive programming, I added to this 2010s too. So reactive programming is just yet one more thing to learn. I respect the fact that you had to learn all these other things in some cases before you could even get here. And our brains might be melting down to this point. But if you do all these awesome things, you can be like the mythical beast, the GitHub unicorn. That's who that is, that snarly fellow there. So I'll just take you back quickly to 1994. I saw in Rez's presentation, he mentioned Mosaic also. I was so excited because that was my first browser, the Mosaic browser. You might have remembered that it came from NCSA. Just so everyone knows, Navigator was not the first browser, right, Netscape, and nor was Apache the first web server. I've had that discussion way too many times with people. Mosaic actually came to market by Spyglass, if you remember Spyglass, and they licensed it to CompuServe, which is how I actually saw it, O'Reilly, which I saw it from that perspective too, and it also became the first Internet Explorer. So we've actually changed a lot since then. Keep in mind, this was our very first, most awesome search engine. You know, I know all you people think Google was the first one. No, this one was the most awesome by far, Alta Vista as an example. And in my case, back in 95, 96 timeframe, I taught myself HTML and I taught myself Java with books like these. This is Laura LeMay's books, fantastic books if you were back in the mid 90s. And you could learn HTML very rapidly. If you put the time in, you could learn HTML because it wasn't even JavaScript back then, right? We didn't really have that as an option. There certainly was no CSS. all we have is straight angle brackets and stuff to put in between there, like the awesome blink tag I put up there. And you might have saw my backflipping Duke because applets were awesome too back then. So my point about all that is to give you a little history to basically say we're moving into a new era now. You can do things vastly different than you did before. And if you want to rethink and are able to rethink the way you think about web applications, there's some really awesome things you can do. And based on Vert.x, right? So we're going to show you Vert.x. We're going to give you a better drill down on Vert.x in a second. But I just want to make the point that I copied and pasted this directly from the Vert.x website. And it says Vert.x is fun. And I think that's the most critical attribute of Vert.x that I find that I enjoy working with. So we're going to show you Vert.x, and hopefully you'll find it to be fun too. As a matter of fact, I want to go ahead and just start with a really fun demo, just to kind of make the point of how much fun you can have with very few lines of code. So what I need you guys to do is do some drawing for me, like you just see here. This is actually the last session I ran, and that's actually what we got out of this, folks. So I'm actually logged in here to a server. Okay, so I'm running on an EC2 instance out there in Amazon land, and I have a bunch of stuff out here. But I'm going to bring up a server. So by default, you operate Vert.x typically as a fat jar architecture. I'm going to go ahead and run it real quick. So start a server, jar, and we'll talk more about this in a second. I just want to kind of show you how much fun it is. Let me bring up my server here. Okay, we're deployed the server. Let me bring up my browser, and let me make sure we refresh here. Okay, you see I refreshed, and I connected. And then let me bring up another browser window, because we're going to show you how this works. So let's go over here. And let's make this a little bit bigger, or a little bit smaller, I should say, so you can see things. So if I come over here and do some drawing, you can see that basically as each stroke falls on the client side, you see it on my dashboard. And to kind of make that point a little bit more, let's see if we can bring up the phone. This my camera is not working too well. Let's see if it'll behave for me. Let's look at the phone here. Okay, so I can, basically draw lines. And actually, you want to see what's in the background here. So as each stroke falls, right there, just on my mobile browser. So this is just a straight up mobile browser, hacked up thing. You can tell that I don't actually make very pretty stuff. And you can pick colors, and you can draw in circles, and you can just have some fun drawing in pictures. Look, we already have a nice little house there. And I'm going to bring up another system. So I'm just adding some more systems to the mix here. So I can kind of watch how this works. Dun, dun, dun. So draw some pictures for me. And actually, if you hit refresh, you actually get a new session, which means you actually get a new palette, if you will, to add things. All right, we got a nice red hat I see showing up there also. But here's kind of the cool part about this. This actually takes very few lines of code. It's kind of hard to describe how little lines of code it takes, because, and I'll show you the code in a little bit, but it's super easy to kind of come in and draw some things. And actually, I'm going to keep adding to mine over here too. Let's just put a little squiggle over here. And watch what I'm going to do also. So it's actually, one thing to keep in mind, it is bi-directional. Let's see if we can do this. This is actually a feature I just put together before we started this call, because I wanted to have some fun with it. Let's go over here. And if you watched my phone, let's see if this works out as I expect to. So you kind of see what it's right there. And right there, and let's see, and unfortunately my camera's freaking out, but if you notice there's a little smiley face now on the phone. I can actually come into the backside now and basically make edits to the client images, if you will, and send those back out to the client browser. So the point of all this is you got bi-directional communication between the browser, real-time communication between the browser and the server, and it's actually super easy. And so we'll walk you through this code in a minute, but I kind of want to show you that fun demonstration right up front. So hopefully this kind of get you guys thinking what we're going to do here. Oh, I love the flower, man. We have some real artists. And here's the crazy thing. I've noticed when I've traveled in Latin America, I get real artwork from those folks. While in North America, you get some, kind of risky stuff. Okay. All right. So thank you so much for that. We'll just leave that running, but let's just jump back into the presentation. Looks like a number of people have joined us here. Okay. So let's introduce you to Vert.x. That little demo just kind of, hopefully what's your appetite. The Vert.x is a toolkit for building reactive applications on the JVM. All right, it's a reactive toolkit, meaning it's a jar file. You can include it inside your applications, or you can use it to build whole applications, whole enterprise applications by itself. There's this little diagram kind of describes all the capabilities. Each of these little boxes actually is a separate module, a separate jar file that you can pull into the Vert.x architecture. By default, the main Vert.x library and the main Vert.x core jar file. Supports HTTP 1 and 2. So in the last session, you guys heard all about HTTP 2. So HTTP 2 supports right here, right out of the gate, and that's awesome. So you can immediately take advantage of that if you choose to. One trick to remember about HTTP 2, if you do decide to use it, you do need to kick your server into SSL mode or HTTPS mode. That's critical because most of the browsers only support HTTP 2 over HTTPS. They won't set up HTTP 2 if you try to communicate over port 80. You need to get out to 8443. The other thing in Vertex core mode, you got the UDP, you got TCP. So you can basically just set up any kind of network socket you want and just listen. So just keep that in mind. Just listen on the port and basically talk to things. And then we also have this thing called the event bus, which you just saw in action. So the magic of the event bus not only extends between all the different JVMs, it also extends out to the browser itself. And we'll show you more of that as we get into it. But you can also do things like integrate with Apache Camel, RabbitMQ, if you want Hazelcast versus Infinispan versus Zookeeper as different cluster managers, you can have those things. It has microservices capability like service discovery, circuit breakers. And one thing here in the middle that's super important to understand is actually polyglot. And I'll show you some quick examples of a JavaScript, Groovy, and Ruby option. But we also have Kotlin support now. So if you saw Bruce Eccles' presentation a couple sessions back on Kotlin, you might be interested in that language, and that's new for Vertex 3.5. All right, let's keep going here. So it is a fat jar architecture. So it's java-jar, myapp.jar, and that's how you would launch it. You don't have to run it that way. I'll show you some different ways to run it. And actually, you can treat Java like a dynamic language, and I'll show you that too. That's a lot of fun. But do think in terms of the fat jar architecture for all these microservices that you hear about these days. So Drop Wizard certainly made a lot of that very popular. Spring Boot, of course, adopted it back in about 2013, if I remember correctly. Vertex has been doing fat jars for a long time as well. And there's also things like Wildfly Swarm and the micro profile options that are out in the market, whether that be Pyara Micro, Wildfly Swarm, Liberty, et cetera, et cetera. So just keep in mind that there's a lot of options in the space, and there's probably a dozen more that I can't remember, like Spark, Java, and a couple dozen others that are out there. But Vertex certainly falls in that category. The thing to understand about Vertex that makes it fairly unique from the rest, it is only async and reactive, okay? That it doesn't actually support, if you will, a traditional thread-bound programming model. There's a nice book here, and since you guys have joined my slide deck, you should be able to get to that link very easily. It's a free download from that'll walk you through a lot of these same patterns and principles we're talking about now. Now, word on reactive. So a lot of people are using the term reactive now. It's kind of overloaded. Everybody's talking about it. If you just go to Merriam and Webster here dictionary, you basically see it's related to a response to a stimulus. That's how we like to think of it. I don't like to think about it as emotionally upset, which is the second option there. A result of stress and emotional upsetness. I like to think of it as a reaction to a stimulus. And so if you think of it from that perspective, it's fully asynchronous. The reactive world is an asynchronous world. And the software that has responses to stimuli. So you basically want to program to events. You want to program to stimuli. You want to program to things that might be happening within the context of a stream. And so you have these concepts of, like on the right-hand side here, reactive programming, an asynchronous coding model, and there are numerous options that are out there, including things like just basic callbacks and futures and things of that nature. You also have the reactive system model, which we'll dive down in more detail, and that's where you actually bring things together holistically. So you could use reactive programming to build reactive systems. And the reactive streams has kind of gotten a lot of buzz of late, and to kind of give you more detail on what those things are. If you look on my left-hand side here, in the reactive systems world, there's a manifesto that's out there. There's also things like the actor programming model. We do think in terms of messages, and we focus on resiliency and elasticity. That's part of the manifesto. We'll drill down more on that in a second, but it's certainly asynchronous in the reactive systems world. And you're trying to build a responsive distributed system. A distributed system meaning there's going to be 15 JVMs or 25 JVMs all interacting together to solve, let's say, a business problem. And you can actually see solutions from folks like Akka, Lightbend, our sponsor today. The Lightbend folks certainly have an option in this space, and Vertex, which is this option from Red Hat. And that's why I'm here to talk about it today. On the other side of the spectrum, you do have the reactive programming. So you might hear about streams and flows and events. You'll certainly probably hear a lot about RxJava. That's a very popular option, RxJava 1, RxJava 2. And the RxJava 1 and 2 programming models, or RxJava 2 programming model is now part of Vertex 3.5. So if you go out and get 3.5, you can just start using Rx directly from that perspective. And the nice thing is it's not just Rx in the traditional model, it's Rx magnified with all the capabilities of Vertex, like the event bus, HTTP input, and I'll show you an example of that later. There's also Project Reactor, and you're going to hear from Josh Long a little bit later on Spring 5 and the work that they've done with Spring Boot 2 and Spring 5 and the work they're bringing to bring reactive to their programming models, an example. And the reactive streams, as I mentioned, is becoming popular. It's just a simple specification that talks, about data flow and back pressure as an example. But it is pretty straightforward. There's numerous implementations of that specification too. So there's the link for that. So I like to think about reactive programming as programming to asynchronous data streams. That's definitely a focus on it. We have the Reactive Manifesto here. And here's the easiest way to think of this, right? It's message driven by default, meaning it's not bound, it's async by default. I'm not always waiting for a response, and I'm not locking and binding threads to wait for that response. So think in terms of purely message driven. You also want to be elastic, meaning in the face of overwhelming load, I should be able to scale out easily. That's critical. And you want to be resilient. In the face of overwhelming failure, you want to continue to serve and be responsive to your users. So if you're overloaded, respond, that's critical. And if you're failing, still respond. Because here's the funny thing about a user. If you're not responsive, they're going to basically hammer you. But you're better off responding with something than nothing. And that's certainly the model you see in distributed architecture, like the Netflix OS architecture, which has things like Hystrix as a circuit breaker. That's where that concept comes from. Vertex has this concept of the vertical. So we run everything on top of the Java virtual machine, even all those different languages I mentioned earlier. And then you have this concept of the Vertex instance. You can kind of ignore that because it's just, running on the JVM. I think of it as the JVM. The vertical is a programmable unit, the component. It's your class, if you will, if you're a Java programmer, but otherwise just a program, or, if you're coming from a different programming language. And then all those verticals, you can run multiple in the JVM. They actually all talk to the event bus. So the event bus is always there for you to communicate across from vertical to vertical to vertical. And that's a critical thing to understand. If you do want to communicate, well, in theory, you could go directly in memory. We don't recommend that. Actually do it all async through the event bus, and then that means you can actually distribute these things in the future, okay? It is based on the event loop architecture. This means that there's essentially a single thread for you to worry about, and everything operates on a single thread. Therefore, you don't have to worry about multi-threaded programming. And you can think of it as this infinite loop that has this queue of events coming in from different event providers, whether they be mouse clicks or get, put, post, or delete in a browser setting, which is mostly what we're here to do tonight. Or one of the demos I love showing, and I didn't set it up tonight, is IoT, right? Streaming sensor data. And basically all those things get queued up in this event stream. And basically the event loop picks up the next event, finds the interested handler, dispatches that event, and then goes back to get the next event. And the handler then in turn finishes up the operation on that, which in turn may create its own events. And again, I'll also come back to the event loop there. There's an event loop per core. So by default, if we see there's 4 cores available to us, we set up 4 event loops. Just keep that in mind because in a Docker setting, this gets a little bit weird. We do a lot with Linux containers, obviously here in Red Hat land, that's definitely a focus for us. And often you constrain your Docker containers just to a few cores. And one thing that's super important to understand about that is Java lies about the number of cores and the amount of memory by default. So you'd have to know that there's some tricks to that because you'll overallocate memory, which causes a blow up, or you'll just overallocate too many threads. Doesn't cause any real problems other than you're using resources you can't really take advantage of. Now there's also a web router. We'll show you a lot of this in a second when we get to the coding part, but it basically takes your HTTP request and maps them to a URL and makes it a simple programming model so that you can actually then route that URL directly to a handler and then provide an HTTP response. And all this is done asynchronously. All this is done through the event loop. If you're familiar with the Node.js programming model and something called Express, it'll look a bit like that. Or if you're familiar with Sinatra in the Ruby world, you'll see some things there too. Okay, here's what this router programming model looks like. You can see it's get, put, post, delete. So there's your HTTP verbs right there. And then there's the URL we want to interact with. There's the parameters if there are any. So, URL parameters in the case of the get or in the case of the delete. And you can see we're using method references here. This : get all, or get one, or add one, delete one. And this is actually one of the examples that you can actually find out there. There's also a static web server for serving static assets off the local hard drive. And you can kind of see it basically says create HTTP server, request handler, and we do the router accept, and then we listen on port 8080 if we want to listen on 8080. Often I still keep to 8080, by the way, though I'll show you some stuff on port 80 as well. Because when you do go to Docker Kubernetes, it maps 8080 to 80 pretty easily for you. Okay, so let's do this real quick. You guys are joining me on the slides. Let's actually try this. Let's have some fun. My camera's freaking out, so let's close that down. We don't want that blinking at us there. I'm going to get back on my server. Okay, I'm taking that other server down. You guys did some nice artwork, though. I can see it. Let's see where'd that go. Not that one. Which window were we in? I've lost track. Not that one. Oh, it was this one, the one we were. Okay, yeah, look at that. All right, good stuff, guys. All right, so we're gonna basically now set up different servers on this server. Let's go here. Okay, and so let's see. Get namespace. I'm gonna see if I'm connected to things correctly. Okay, looks good there. Let's see, new project, and we're gonna go to the vJUG. Let's see if that'll work for me. Okay, let's see again. Projects. All right. So we're going to do some stuff here. We can ignore that part of it, though that's in the slide deck too. But I'm going to show you what it takes to get started. One thing is you just use this Maven plugin from the Fabricate project, and you say I want a new Vertex application, and I am using 3.5, which is the newest one that just shipped. Let's just call this stuff. Let's give it a demo 1.0 snapshot and build my initial vertical. Okay, and you can see we have a POM XML and a source file right there. I can then say Maven compile Vertex run. Now, there's no actual logic inside this Vertex application, so it's not going to really do anything of interest. So let's go over here. Yeah, let's do this one. And let's do this. Gotta type fast. I know people want to see me type. That's exciting stuff, and I don't type very well sometimes. It's nerve-wracking to type in front of a live audience. Let's see here. Okay. So what we're going to do now is just put in the body of our code. You can see this is the default template for a vertical. You can also just set up your own main method and include Vertex directly in there. In this case, this is the default option. So I say import IO Vertex ext web because I want the router. All right, the web module is included now. And let me do a write out. Let's move these two windows closer together. And what happens is it dynamically recompiles as it needs to. So basically it treats Java like a dynamic language, as I mentioned earlier. And again, this is all in the slide deck. Okay, so you guys can even try this on your own right now. Whoop. Let's go here. So you can kind of see it just sets up just like this. Let's go ahead and just go and fill this in now. Router, Vertex, and So I'm just using VI here, obviously, just to see what it looks like. And there you can see it recompiled and redeployed. Again, we haven't done anything yet. So we're going to do some more interesting stuff. So router, get. Let's add, we want just the index, the root there, and handler. Okay. And then context. Now let's just call it RC. Boom, 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 boom. Okay. Move that over. And let's see here. Okay, so if I've done this correctly, actually we can check it real quick. Let me just do a quick write. See, yep, recompiled, no problem. So I really do love the fact that, you know, it just, you can treat Java like a dynamic language. It's just doing a recompile for you automatically, but it is super lightweight and makes it pretty easy. So let's do this now. So we're going to basically do RC dot. So request, and so we need the request, and we want to get the response object. And out of that, and then end, and then let's say hello. And if I did this all right, we'll find out if we did or not. I like to add a little date action. And let's see if I got that syntactically. Oh, I got it wrong there. RC, variable RC, routing context. I got it wrong. So let's get that right. Let's see here. What did I do wrong there? And actually, I normally like to just call this request. So let's just do that. Oops, if you did it. There we go. And and let's do that. And let's just do this, make this a little bit easier. Up. All right. Let's see if I got it right this time. And let's see if it'll recompile. Okay, a little happier now. So I got that sorted out correctly. And whoa, we got to add a little bit more logic to this. So still within the start method, we got to actually listen on port 8080. So Vertex, create HTTP server, capital H server, and request handler, and we're going to basically put in the router. Okay, and actually it's ::: accept. So another method reference there. And then we need to listen on port 8080. We'll just listen on 8080. We could listen on 80, but let's go 8080. Let's see if I did that right. And let's see. Okay, it says it's redeployed. So let's go try to hit it and interact with it. So web.red, want 8080. And there we go. All right, so there's my little application so far. Nothing extravagant there. Let's just move this down here a little bit. And let's actually keep interacting with this a little bit more, because one thing I always like to add is the host name as an example, because the host name is interesting to me, and you'll see why in a second. All right, so string host name equal to system get env get or default and host name and whatever. Okay, let's see there. And sure. Don't go to sleep, machine. And then let's do this. Host name. Okay, let's see if I did that correctly. Just writing it out. Let it redeploy. There we go. And refresh. All right, so now we have the host name too. And so, you know, if you guys are hitting this, we could even see that also. Let's do this. You know, after print line. So setting up a web server, setting up a simple endpoint like this is super easy. Stuff here, okay? And then we can just check that out. So there it redeploys, and as I interact with it, all right, so there we go. So what you guys are tapping away at it there, fantastic. Now, I'm gonna shut it down because I wanna show you one other thing. So I just killed it, so you're not interacting with it anymore, but I wanna show you this one other trick we have here, and that's the other Fabricate Maven plugin that we have. And I'm gonna basically run it right now. I'm just gonna copy and paste that directly. And if you remember earlier, I actually have a Kubernetes instance. So Kubernetes, get namespaces running out here. And okay, good. And then what I'm gonna do is simply Maven Fabricate deploy. Because I didn't actually build a Docker file. I don't have any Kubernetes YAML, but we have this other Maven plugin that'll take your fat jar architecture, and it actually works on Spring Boot applications, Wi-Fi Swarm applications, Wizard applications, Vertex applications. It just takes your fat jar application and makes some default assumptions for you and pushes that out to OpenShift or Kubernetes. OpenShift is Red Hat's supported version of Kubernetes. But let's go over here and find my browser. Okay, let's see here. Yeah, there's the vJUGs project that we added. Okay, and it's still going through the process of pushing that out there. So what is happening? It has to do a full build. It has to build that fat jar, and we could have just done that separately. And then it basically says, you know, let's actually map it to specifically something called a S2I strategy, source to image strategy. Basically, it takes any sources, maps it to an appropriate default Docker image that we have in the registry, and then puts that in the Docker image and launches it. So you can see now it's been scheduled. Here's the OpenShift user interface. You can see that it's been scheduled across the Kubernetes cluster. It's now out there and running. And let's see if our route got set up correctly. Not just yet, so we need another second. So right here, it's not quite set up as far as my route goes. You can see what the route is, but let's see if we get that coming up here. And actually, while we're waiting on it, let's actually start another instance. Okay, boop, 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 boop. And we'll walk you through some more of the code that we showed you earlier. I'm just starting another instance of this server. There we go. And the reason I'm starting a second instance is you can see there's the first one that we have there. So you can actually, there's the host name. So each of these individual Vertex applications think it's running on its own unique computer. That's the beauty of this cloud architecture you get from all these different parties. Let's see if we can do this. I want to see if I can bring up another option here. And okay, so not that. Dun, 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 dun. Let's see. Let's try Opera. Let's try Opera real quick. If you basically, Kubernetes is mapping a sticky session by default into it. And so I'm trying to get it to show you the other host name. So there we go. So in this case, I've been load balanced. It does random load balancing by default. So we're not here to focus on anything Kubernetes and OpenShift related, but you know that kind of shows you how quickly you can stand up a server, and you guys could go to this URL too, right? Okay, so let's jump back into the slide deck here and show you some more cool stuff. Now, the Vertex event bus is kind of something we showed you earlier. I want to walk you through some more detailed examples of it and make it more interesting for you. But the concept of the event bus is distributed across multiple JVMs. So it is in existence across all the different JVMs as long as they can find each other. So just keep that in mind that they have to be network visible to each other. And that can be a bit of a challenge depending on how your networks are laid out. But by default, they'll find each other, cluster automatically, and then they make direct connections to each other to spread event bus messages back and forth. So let's kind of show you that example. Okay, I'm going to go back over here now. And actually, let's show you this example. And I want to show you another example just because it's kind of interesting. I actually have a couple little applications out here. I have a Spring Boot application. So let me run it real quick. And it's just standard Spring Boot. We can basically look at the source code over here. And then what we'll see is when Josh comes online, he can show us something different. But if you just take a traditional enterprise Java programming model, like you would in let's say, a Spring Boot application, it just, it's pretty straightforward. REST controllers, request mappings. That's very straightforward. It's the same is true of Java EE, right? You just have different annotations, but the business logic looks identical. The only difference is what annotations to use, especially for a REST endpoint like this one. But what I want to show you is that because by default, a lot of people misunderstand this, it actually sets up a thread pool, and I set it up for 25. So by default, I locked Tomcat here and Spring Boot down to 25. And let's do this. Okay, let's API goodbye. I spelled goodbye correctly. All right, there we go. So I made my connection over here for API goodbye, and you can see I'm interacting with it. So I mentioned earlier that you want to be resilient, you want to be elastic. So what I'm going to do is I'm going to actually send in way too many transactions for the system to handle, and watch what happens. Basically, if there's no thread to work on your job, you wait, right? So this is an example of not being responsive. And so we've had this forever in the traditional enterprise Java world, if you will. But you can see you do get a response once a thread becomes available. And of course, I'm actually sending in way too many requests. So basically, you have to wait to the next round of threads become available. So this, well, we have reactive programming now in the Spring world, and we have asynchronous programming certainly prior to this in Java E world. This was the default way that things worked. I'm not picking on Spring. I'll pick on Wildfly too, because that's the world I come from. But if you look at it from the Wildfly standpoint, I'll just show you that code again. Right? It's just at get the path thing, and you can see the business logic. And what this business logic is doing is actually silly. It's just calculating pi. I didn't put in thread.sleeps because I think that's just inappropriate. It's just calculating pi, which takes a bunch of CPU crunching. It just takes time to respond. That's all. And then let's go over here. So we have that up and running. Where'd my little browser window go? Oh, I lost it. And here we go. So let's connect to over here. And the same kind of concept so there's Wildfly Swarm, and we're interacting with it. And if I come over here now and then send too many transactions in, like before, okay, so we're going to basically fill up the threads, make them all busy. That's all it's doing, make them all busy, same thing as before. So while this is the Wildfly application server, while the other was Tomcat built and based in Spring Boot, this is the default way you have to think of the world in an enterprise Java world. Okay, let that finish up. And then let me just rip that one down. So I'm just starting all these servers. If you guys are interacting with them, you'll see them come up and go down. Let's see there. Yep, I'm killing you. Let's bring up the Vertex one now. So Vertex sets up a little bit different. What I do with that line of, well, I lost the line that it takes to start it. I think I still have it over here. Yep, fantastic. And there. And let's bring up the other windows now. And where did I do? You see it comes up very quickly, but let's see here. There we go. There's my Vertex application. So same thing as you saw before, but in this case, when we actually overwhelm it with too much load, it gets slow, but it's still responsive, right? We're eating all the CPU on that server, but the foreground thread is always available to you. And that's really the difference, right? Basically, we knew that these jobs were going to take a long time. We put them in a background thread pool. But the nice thing is the system's always responsive, because what do users do to you if you're not responsive, right? They're basically going to come in there and actually hit you up by hitting refresh, 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 because that actually helps you as a web programmer. Refresh, refresh, refresh when you don't respond, right? Because if you're down and dead, kicking you while you're down is actually a good thing. Well, it actually doesn't work out that well, but funny enough, we were all impatient people too, and we do the same thing. But let me show you a couple other examples here. Okay, ts- what is that? Oh, I guess I didn't say Java. Okay, let's go here. I want to now show you, we showed you that, okay. Oh, let's show you this one. Let's do this one. Okay, here's another web server, an example of push. And actually, let's actually show you the code real quick. Where'd that one go? Oh, here it is. Okay, what we're doing is we're setting up another web server. This web server is a little bit different than what you saw earlier. We have the start method as before, we have the routers before, but we have this thing called bridge options. And you can see we're basically saying outbound bridge options, and it's like a firewall. and we're saying we want to basically pop through that firewall this news feed, or my feed. And that means messages showing up on that event bus message address will actually go out to the browser itself. And you can see we're using sock.js to set up that browser bridge. And the cool thing about that is, let's actually show you in the browser real quick. Let's see. This one I think I have running on port 80. Yes, there we go. So it's basically, it says aloha, and then it's basically pushing messages out to the browser. So if you go to web.burr right now, you're going to get these messages also. So this is the server pushing to the browser. And the cool part is, it's just this one, really the one line of code down here. Basically, every 1.3 seconds, send out a message to my feed, web server now, and it looks like this, okay? And there's some client-side code, client-side JavaScript code, and we'll show you that real quick. That basically says, where's my register handler for my feed, and then it basically will display or basically prepend that message from the server. Now, let's get a little bit crazier with it. That's just kind of boring, so let's actually make it a little bit more fun. As I mentioned earlier, all JVMs are first-class participants on that event bus. So let me bring up a Java publisher on the event bus. So this is a separate JVM now, separate from the web server. It's going to join the cluster, and then basically what happens is for my client, it's going to get yellow messages for the Java messages versus the white messages coming from the server. And it's just kind of funny, I know, but you know, let's go over here now, and let's set up a Ruby publisher. So, it helps if you type things correctly. So all these guys are going to participate. I can bring up another window here, and oops, I was already in the right place. And then let's try a JavaScript consumer. Okay, so publishers and consumers, or you can see Ruby's kicking in now. That's those red messages. But to kind of show you the code real quickly, the Java publisher is very straightforward, right? It's got a periodic here, and we're going to do an event bus publish with a message saying Java now. If I look at my Ruby publisher, my publisher Ruby, it's very similar. It's got a periodic, and it's got a event bus publish, my feed, and it says Ruby now. So if we have a JavaScript consumer, my consumer.js received, let's go look at it real quick because I started it. So he's receiving all those same messages. So everybody's communicating together. So that's basically how you saw what we did when we did that finger painting game, right? We basically had everybody living on the event bus, including the browser itself. And that makes it kind of fun and kind of interesting. So you can get all those messages. And actually, I can shut parts of this down now. Let's kill Java, and let's actually kill Ruby. And you'll see those messages fall out, and it's just web server messages now. And if you look back at my JavaScript client, it's only seeing web server messages, and I'll kill it. And I can even kill that server. All right, so several of you join me. I can tell because it says a socket was created. So by default, the event bus to the browser is specifically using that sock.js bridge, and then it's actually using WebSockets when it can to manage that. My server here is a little slow. There we go. Let's see. Sometimes I have to kill these processes. Let's check them out real quick. Oh. Yep, we got too many of these guys running. Let's see if we have to kill one of these guys. Sudo kill -9. Yep. Do we have any more? Oh, man. So because of the way the server is configured, it's fairly weak. I just actually run a very small instance. And then we have to manually kill some things because it takes a while for those JVMs to shut down. Okay, and let's do that. Okay, do we have any more? One more. All right, let's do that. My server's been a little bit overwhelmed. I left it running way too long at this point. But let's come back over here now, and let's just double check that one more time. Okay, let's show you this little chat example, which is similar to what you saw when it came to the fingerprinting game. In this case, I'm going to do Maven. Let's do that. Sudo Maven compile Vert.x run. Okay, so you have the jar way to run it. You can do it with the Eclipse plugin way to run it. Let's see here. Okay, this is a super silly little game. Basically, you can type in a little chat, and it's bi-directional. So if I come back over here, let's move this over here, and you can see, oh, cool. Some people already chatting with me. Thank you guys so much. Cool. There we go. And so that makes the demo much more interesting if we can all chat together. Stuff happens here. Okay. And you guys, nice thing about folks down in Ecuador, you keep it very clean. I like that. I appreciate that. Thank you so much. But let's just look at the code real quickly because I think it's interesting because it's, again, another straightforward example of what that could look like. Let's go back over here. Okay. Again, the chat to client we're going to register a handler. It's looking for the data coming from the server to the client. Register a handler there, and all it's doing is appending to that div tag the message coming through the channel there. And then every time you hit enter, right, the 13 key here, it's going to take that message and publish it to the server. So bidirectional input and output. This is really all the logic of the application, really. If you look at the little bit of Java code we have here, it basically has inbound permitted and outbound permitted to those two addresses, like you see there. It sets up the sock.js handler. I added this kind of stuff. I like seeing who the user agents are, who's connecting, things of that nature. You can see the event bus route has to be exposed. And then, of course, the static web server, which basically serves out things from web root, resources web root. So those guys got served for us. And you can kind of see this guy right here basically reflects server messages to the various clients. And it goes out the door. You guys have been going crazy over here. Wow, good job there. Okay. But that's an example where a chat client is super easy. And you can see the different people who got connected there. Again, it uses WebSockets by default. It'll fall back to SSE or long polling if it needs to. Now, we got some more fun stuff to show you, actually. So I'm going to kill that one. But I want to show you another example, and this is, I just have it running on my local machine, but I think it's super powerful. So this is one use case that you might consider. So as I mentioned earlier, we also support the RX Java programming model, and I have lots of examples of RX Java at the base level. I need to upgrade my RX Java too now I think about it. I haven't had a chance to do that. But one of the things we've done is we've extended the RX Java programming model. We didn't invent our own thing that was kind of funky or weird. We stuck with the standard, in this case RX Java, and the concept of observables, flowables, singles, and maybe in the case of RX2 is new. So you can see this is used the observable API. And this is an example where on the server side, we're communicating like a client to other services. So if you are dealing in a microservices world, or you're dealing with that kind of API gateway level of architecture, you basically can write a single endpoint that is then interacting with all the other endpoints you have to interact with, and it's doing this fully asynchronously. And what's even better is as these users are being streamed back, it then is taking each user in the stream and then invoking the actual details. Basically, in this case, it's getting the actual user details for that user, and it's getting all the followers for that user, okay? So it's basically going out and hitting multiple API calls, but based on the streamed in data of the previous API call. And then one nice thing about the RX Java programming model, you see it stacks up top to bottom pretty nicely, pretty easy to read for all intents and purposes. But you have this concept of zip width. So this basically says aggregate all those JSON responses, and then it doesn't actually execute. So it's lazy by default. It doesn't execute to hit the subscribe method. So let's see here. Let's see if I can run it real quick. And this is just running on my local machine, so you won't get a chance to see this, but we can interact with it here. Let's go open this up. Localhost 8080, and you can see in this case, because I'm not really using authentication, those keys and they're bogus, and you notice they're commented out, it actually only gives me a subset of data, but you can see what the aggregated response looks like. So think about what you could do with that. If you are dealing in a microservices architecture or any form of front-facing business-to-business API or anything of that nature, you can interact with all the other backend services, kind of behind the firewall, if you will, and then expose this one endpoint to the world at large. So that's actually probably the most popular use case for a Vertex-style application. Oddly enough, it's the most popular use case for a Node.js application also, because if you think in terms of defining APIs and how easy that is, and there's actually a really nice Swagger module, by the way, where you can actually define everything in Swagger, and it gives you the full endpoint for that. I just don't have it running here locally. But you can actually build a nice composite or aggregate API with the solution. So nice thing there. That's the wrong presentation. Let's get back over here. Let's see. Let's make sure we cover a little bit more ground here. Okay. So there's a bunch of demos that I mentioned earlier. So just be aware of those. Also, and actually, let's just go to this link real quick. I did this for JFocus last year. We built a series of tutorials. So again, basic RX programming model, how RX integrates with Vertex, Vertex Web, which you guys have seen a lot of, the event bus, the painting, so the finger painting thing. There's a version of it out there in this tutorial, along with the composite thing I showed you. Even my IoT streaming sensor data examples all there. So all that's out there in open source for you guys to have some fun and check it out and tell me how horrible of a coder I am. So feel free to do so. But I have one more demo to show you. Okay, let's kind of keep moving here. All right, that's this demo. So this is where it gets super interesting, and then we'll go and wrap up. So let me bring up my browser. You guys are going to switch URLs now. We're not going to use the one we were using before. Okay, we're going to go to this one. Go to game.burr.red. Let me actually move this over here. Let's make this a little bit prettier, get it the right shape. And actually, since I resized the window, I'm going to do that. And then you can also bring it up on your phone. It's actually easier on your phone for those folks to be like, oh, I want to run this on not my phone. It is actually easier on your phone. And what it is, let's see here, is a game. Oh, we made everything too big. Let's actually do this. Let's see here. We're going to turn this off, change the color. Whoa. Okay. Game.burr.red. You don't want to close the window when you're trying to interact with it. Okay, come on. And I want the admin. There we go. And I have my password saved, luckily. But you guys pop some balloons for me, and I'm going to show you what this thing's doing. But let's do this. Actually, we can make the balloons smaller and faster. And we're going to turn this guy off. And let's go here. Got to hit the right buttons. So I'm basically making real-time updates to your phone right now. So if you're interacting on your phone, you're actually going to see these balloons flying across there. Again, as I mentioned, it's actually easier to do on the phone than it is on the computer. But let's look at our scoreboard. Let's see how you guys are doing. Okay, we got 8 people in concurrently right now. And then, of course, they're popping balloons like crazy. It's actually gotten kind of hard, I know, because I made it kind of hard. But let's look at our leaderboard. So what's happening is this is a nice example of a real-time game. This is kind of one of the cooler demos that I have. But as you guys are popping balloons, you're making changes and seeing those changes show up here in real time. So if I can manage to click some of these balloons, which is kind of hard, like I said, on my mobile, I'm going to click on my mobile device where it is easier. As everybody connects, you pop balloons, you show up on the board, and you'll notice that your score is changing in real time. Also, your achievements are being calculated in real time, and dashboards updating accordingly. And actually, what we can do is make this a little bit easier for you. How about that? Let's make the balloons big again, make them a little bit slower, make them nice and bright so they're easy to see. We can actually, let's make all the balloons count 10 points each. Okay, and I can change the color to green to kind of make it obvious. So now you're in green mode, the big fat balloons. So we should see the scores really rocket up now. And you can see there's a bunch of you playing, and you've already got 900 transactions to the system. So this concept is all, Vertex, in this case, managing WebSockets on the back end, where when you pop balloons on the front end on your phone, it's then showing these the data in my 2 dashboards here. And actually, let's explain that a little bit better. So let's try this real quick. Boom. Okay, so we just paused you, and so you should be kind of frozen now. Sometimes there's a bug there, and you might not be completely frozen, but looks like a couple people are still interacting there. But here's how this game works, and I'll show you this in a. Let's go back to my slides here. The nature of this game is actually pretty interesting. So the client side is just pure web, right? We didn't install anything on your client. It's just web. It actually operates 60 frames per second to give you that nice scrolling user interface there. It works really well. And then what happens is with each balloon pop, you're getting a transaction back to the Vertex game server running on another JVM, a single JVM in this case, on one of my servers. It also interacts with in a microservices way with another achievement server to discover what achievements are available. Then it interacts with a traditional Java EE on JBoss with rules, that's the rules calculation engine, that basically say, did you achieve the achievement? And it also writes it to a database. So it's actually, this is very traditional architecture in this case, but we're managing all through this one asynchronous engine. That's how it scales so well. Like I said, it's just a single JVM. We run this up to 1,000 concurrent users easily and more with tens of thousands of transactions flying through the system in any given moment. And then, of course, it updates all my messages to my dashboards. And if you noticed on the phone itself, you're getting messages back from the server based on the achievements you've achieved. So if I come back here now, let's see here. Let's go here. This guy's running. Oh, I lost my dashboards. This problem with thing, we have just too many screens to look at here. So you guys are going to town there and killing it. Looks like Fern Gull is in the lead there. Let's actually, you notice the golden snitch achievement. I turned it off briefly. Let's turn it back on. And actually, we'll make the change again. Let's make red balloons for Red Hat count a lot. There, we'll go up to 100. All right, there we go. We pushed the changes out, and you're going to see those things going now. And there we go. So the team who helped me build this thought it would be super funny to add my face to it as an example. But there you go. You can kind of click them, and you see those little things at the bottom down there? Those achievements are coming back from that Java EE engine, the traditional apps server, back through Vertex and out to your browser, all in real time there. And you can see we're scoring like crazy there. Okay, so that is kind of the ultimate cool thing I could show you. So let's go game over. All right. Thank you so much for playing along with me. Thank you for all you folks down in Ecuador. Hopefully you had a little fun with that as an example, but hopefully it does give you a feel for what can be done from a Vertex world when it comes to really cool web applications. Let me jump back in my browser over here. Okay, the repo, the Balloon game is all out there in open source. I've had different people run off with it, do different things. That's kind of cool. And definitely different people at Red Hat. There's also a bunch of other awesome resources I'd point you to. There's that ebook I mentioned earlier from Clement, but he also has a great workshop, a microservices workshop. The documentation and GitHub link is here. There's the GitHub, or there's the link to the Write ebook. If you're interested in create, read, update, and delete traditional databases, we have a wiki tutorial to walk you through how to do traditional databases, but again, full async reactive. We have the forums. There's also great examples of Vertex Awesome. And then I have the examples I showed you also. I built a bunch of examples there. But let's see if we have any specific questions or any thoughts, randomness, and we'll just kind of leave that there. There's the link to the slides. And then if you're interested in more kind of content like this, I run a special program myself called Damnation Live, which we do live events about twice a month ourselves, kind of like vJUG. So Simon, did you stay with me all this time?
Absolutely, I was popping balloons, man. So yeah, I tell you what, share that with me offline, and we can I'll promote that to the whole virtual jug actually, and we can get some cross-pollination going on that.
Okay.
So any questions? Let's jump to the Ecuador jug. I think one of the reasons maybe was because you were having a YouTube stream going at the same time. Maybe that was slightly delayed. I'm not sure if that's the case, but if you unmute, we'll see if we're see if we can hear you better this time. So any questions?
No, it was a cool presentation, but we don't have questions.
Okay, awesome. I've got a question on the live session. What is the difference between Vertex, Java 9 Reactive Streams, and RX Java?
So Reactive Streams, RX Java. So RX Java is specifically for reactive programming. And so it's just its own individual toolkit, but you can't do a lot with RX Java all by itself, right? It's super neat. It's, for instance, it's part of Hystrix, and that's where they use it over at Netflix land. It came from the Netflix people also. So what we've done is we've embedded RX Java within Vertex. So now you can do things like I showed you in the demo there, where you can actually use it as an example to communicate to a bunch of HTTP APIs, right? So you want to use RX Java to talk through it as HTTP and out the other end as HTTP. That's an example where we've kind of extended it to go a lot further with that basic programming model. So that's actually really neat. And then Reactive Streams is a specification that's out there. You can go to reactivestreams.org, and it's just it's actually not that complicated. And it's basically just so people can have a portable programming model against a stream, right? A reactive programming model against a stream. So a number of people have implemented it. That includes Vertex, as well as options like I believe the Akka team has done it as well, and Akka Streams. And then you also see that on the Spring side too.
Okay, awesome. We actually only have 1 minute left between right now from before Matt Rabel's talk, so we better close up. And I'll say a massive thank you to Burr for his first vJUG session, right? So
yeah.
Hopefully the first of many. And yeah, looking forward to your next, hopefully. Thank you for supporting vJUG24 and supporting the community, and also thank you to the Ecuador Jug for being a part of vJUG24. So see you soon. And
thank you.
For everyone else, we'll be taking a 30-second break and going live again with Matt Rabel, front-end development for back-end developers, very shortly. So
and I bet we could talk Matt into inviting ourselves down to Ecuador. We should try to think about that.
We should do it live from there next time, shouldn't we?
Yeah.
Cool. Thanks very much, guys.
Bye now.